So now that we've seen how to find the x and y intercepts, I'm going to show two graphs just to see how you're going to graph this. So how I would prefer to graph this is I like doing the chart with plugging in the zeros. So I know to find my x-intercept, I'm going to plug in a 0 for y, and to find my y-intercept, I'm going to plug in a 0 for x. So if I plug in a 0 here, really you can skip this step. If 0 gets plugged in here, this just goes away, so you're left with 2x equals 12. So if you divide by 2, x equals 6. If we were doing this on paper, I would have you cover this value up with your finger so you could see it's just 2x equals 12. So your x-intercept is 6, so you can go on the x-axis to 6, put a point. Your y-intercept, instead of crossing off the y, you're going to cross off the x. So for the y, we would cross off the 2x, because you'd be plugging in a 0 here, so it equals 0. So we've got 4y equals 12. So you would divide both sides by 4, so y equals 3. So your y-intercept is 0, 3. So you would go up to the point 0, 3 and put a point. Then to finish off your graph, you would just draw a line connecting them. And now we have our line. I'm going to show one more example using a negative value. So here, I do find that people sometimes will forget to keep the negative with the 6, so that's something to watch for. So to find our x-intercept, we're going to plug in a 0 for y. So if we plugged in a 0 for y, that would equal 0, so we're left with 9x equals 18. So divide by 9, x equals 2. So you'd go to 2 on the x-axis and put a point. Then for our y-axis, we are going to plug in a 0 for x. So 0 goes in here, so that's gone. So I'm left with negative 6y. So make sure you keep the negative, equals 18. Divide by negative 6, you get y equals negative 3. So you'd go to y is negative 3, put a point. So your line is going to pass through those 2 points. If you really hate this x-intercept method, you could also try that reciprocal method I showed. Another way you could solve these is some people really don't like intercepts. They really prefer y equals mx plus b. So sometimes that'll work, sometimes it won't work as nicely, but I could show an attempt on this one. So when you do this, you want to get y by itself. So your goal is to get this alone. So I'm going to start with moving 3x to the other side. So I'm going to do minus 3x, minus 3x. So we've got 5y equals 15 and negative 3x are not like terms because this has an x, this does not. So we're just going to write them next to each other. Normally in the equation x comes first, so I'm going to actually put the x first. So I'm going to have negative 3x, and then it's a positive 15, so plus 15. And then I'm going to divide both sides by 5, and make sure you divide every single term by 5. So what we're left with is y equals negative 3 over 5, x plus 3. The reason I kept this as a fraction is this is our slope. So when you graph this, you'll start at the positive 3 as your y-intercept, and then you'll do a slope of negative 3 over 5. So down 3, 1, 2, 3 over 5, or up 3 to the left 5. And then you could connect your points. This would have worked to the other method as well. You could find like the y-intercepts, the x and y-intercepts. But if you like y equals mx plus b the best, this is another way you could do it. All right, happy graphing, and thanks for watching.